So let's take a look at the mean value theorem for derivatives. So in order to use the mean value theorem, your function must meet two conditions. So the first one is that the function, or f of x, is continuous on the interval from a to b, and yes, it's got to be throughout the entire interval, including the endpoints a and b. And then number two is that your function has to be differentiable on the open interval from a to b. So it doesn't have to include the endpoints a and b, but it has to be differentiable in all points between those two endpoints. And if it meets both of these conditions, the function, then at some point the tangent line, or the instantaneous rate of change, will be equal to the secant line, or the average rate of change. And in order to find that exact x value, you can just set the derivative, so f prime of x, or the instantaneous rate of change, equal to the average rate of change, or the secant line, which is just y2 minus y1 over x2 minus x1, or it's easier to write it as f of b minus f of a over b minus a, since we're talking about b and a, and those are our interval points. So now looking at the first problem, y equals 3x squared plus 2x plus 5 on the interval from -1 to 1. In order to see if this fits the mean value theorem, we have to first see, obviously, if the function is continuous on the interval from a to b. And since this is just a standard quadratic polynomial, it is going to be continuous, and if you want to double check, you can use your calculator, and the graph will look something like this from -1 to 1. So yes, it is continuous. So now that it is continuous on the interval from a to b, we have to now check if the function is differentiable on the closed interval, or the open interval from a to b. So excluding the endpoints a and b, so if this is -1, we're going from -1 to 1. -1 is our a, and 1 is our b. Excluding those endpoints, is the function differentiable everywhere in between those endpoints? And the answer is yes. It's basically a smooth continuous curve, and there are no sharp turns, corners, cusps, or discontinuities. So it is differentiable on the open interval from a to b. So now what we can do, now that it has met both of the conditions, is that we can set the derivative, so f prime of x, equal to the average rate of change, or the slope, so f of b minus f of a over b minus a. So in order to find our derivative equation, we can just derive our y. So the derivative of 3x squared plus 2x plus 5, so f prime of x, or y prime, is going to be equal to 6x to the first plus 2. So now we can use this formula and say that 6x plus 2, or f prime of x, is going to be equal to f of b, and remember our b value is 1, so f of 1 minus f of a, and f of a, our a value is -1, so f of 1 minus f of -1 all over b minus a, so 1 minus -1, which is just going to end up being 1 plus 1, which is 2. So once again, 6x plus 2 on the left side of the equation. And then now, in order to find out what f of 1 is equal to, we're going to plug it into the original equation in order to find out what f of 1 is. So when I plug in 1, I'll get 3, or 3 times 1 squared, which is just 3, plus 2 times 1, which is 2, plus 5, minus, when I plug in -1 into the original function, so then I'll get 3 times -1 squared, which is 3, once again, plus 2 times -1, which is -2, plus 5, all over 2. So then when I simplify, we'll get 6x plus 2 equals 3 plus 2 is 5, plus 5 is 10, minus 3 minus 2 is 1, plus 5 is 6 over 2. So then 6x plus 2 is going to be equal to 4 over 2, which is 2. If I subtract over the 2, 6x equals 0, and then x will equal 0. So what this tells us is that at x equals 0, at the specific x value of 0, the instantaneous rate of change, or the tangent line, is going to be equal to the average rate of change, or the secant line. So for number 2, we have y equals e to the negative 2x, and we're going from the interval from 0 to 3. So obviously, first step is to figure out if the function is continuous on the closed interval from a to b. And if you were to graph e to the negative 2x, it'll look something like this, where it's a smooth continuous curve, and it gets closer and closer to 0, or the y value gets closer and closer to 0 as you approach the x value of infinity. And the endpoints are from 0 to 3, so we're basically looking from here to somewhere around here. So from the points a to b, or from 0 to 3, the function is continuous, including the endpoints as well. So that works. Now for number 2, is the function differentiable on the open interval from a to b? So excluding the endpoints, yes, it's a smooth continuous curve, so the function is differentiable on every point between a and b. So now that it has met the two conditions, we can set the derivative equal to the average rate of change. So in order to find the derivative, we can just derive e to the negative 2x. So remember, the derivative of e to the u is e to the u times u prime. So if our u is negative 2x, then y prime, or the derivative, is going to be e to the negative 2x times negative 2, or negative 2 e to the negative 2x. So now we can set our derivative, negative 2 e to the negative 2x, equal to the average rate of change, or f of b minus f of a over b minus a. So once again, we're going from a to b, so a is our 0 and b is 3, because those are our interval points. So f of b, which is f of 3, minus f of a, which is 0, over 3 minus 0, which is 3. So once again, I'm going to write the equation down here. So f of 3, once again, I'm going to plug it to the original equation. So when I plug in 3, we get e to the negative 2 times 3, so e to the negative 6 power, minus f of 0. So when I plug in 0 to the equation, I'll get negative 2 times 0, which is 0, and e to the 0 is 1, over 3. So now what I can do is divide over the negative 2, and dividing by negative 2 is the same thing as multiplying by the reciprocal, or 1 over negative 2. So then we'll get e to the negative 2x equals e to the negative 6 minus 1 over negative 2 times 3, which is negative 6. So in order to isolate x, we have to somehow get rid of this e. And remember that natural log and e are inverses of each other. So if I just natural log both sides, I'll get rid of the e on the left side. Then because the natural log of e is just 1, so that cancels. And that negative 2x can come down, so we'll get negative 2x equals the natural log of this whole entire thing. So e to the negative 6 minus 1 over negative 6. And then finally we can divide over the negative 2. So then the final answer will be x equals, I can just rewrite it as negative 1/2 times the natural log of e to the negative 6 minus 1 over negative 6. And that is the final answer.